Let's start the demonstration now. So the thing is, challenges before Kafka. So let's start like that. So first of all, let me tell you one sample scenario like before Kafka, what was the challenge and why Kafka came into picture. So let's see that. So the thing is, we have a source system and there is a target system. Like there are two computer systems, there are two applications, and they want to talk to each other. So they want to exchange the information. So they want to communicate with each other. So the thing is, in the industry, right, two systems are going to talk to each other for happening some business. So they have to communicate to each other. So right now we are talking to each other. Like I'm a source system and you all are target systems. I'm talking to each other. And why I need to talk to each other? Why I need to communicate to you? Because ultimately some business is going to happen in the backend, right? In the same way, when two systems are talking to each other, it means some business is going to happen at the backend. So the thing is, source system needs to transport some data. So source system simply directly connects to target system and it can transport the data, and it look like very simple, right? Now, see this diagram. Now I have four source systems and I have four target systems. Now each and every source system need to talk to each and every target system. Now establishing a direct communication, you see the diagram how complicated it is. When there are just eight systems out of eight, four are source systems and four are target systems, the architecture becomes complicated. But in the real time, if you take any project, there would be millions of systems, there would be millions of applications. Now to establish a communication between all, I mean among all the applications, among all the application systems, would be really highly tough, and managing those systems are also becomes very complex, right? So the thing is, when systems are getting increased, when applications are getting increased, establishing a communication among the systems, establishing a communication among the applications will become a highly complicated stuff. So to make this complication simple, Kafka came into picture. Okay, now let me explain you one simple scenario. What is the challenge in managing the communication among the applications? Simple. So for example, if you have four source systems and six target systems, now to establish a communication among these four plus six, 10 systems, we need to write down 24 integrations. 4 into 6, that is equal to 24 integrations. And each and every integration, there would be a lot of difficulties we need to overcome. So that in terms of protocol, in terms of data format, and in terms of data schema and evaluation, each and every integration we have to overcome all these things, and then you have to develop 24 integrations. Now designing 24 integrations taking time while overcoming these protocols. Now designing the communication among the millions of applications, just imagine it will take lifetime, not even lifetime, right? It's highly complicated. So to simplify this communication among the applications, Kafka came into picture. Now you see this diagram. I have source systems and I have target systems. So each and every source system has connected to something called Kafka. Now all the source systems connected to Kafka, all the target systems connected to Kafka. Now Kafka is like a messaging router. It's a messaging backbone among your applications. For example, a source system wants to connect to, like this is source 1, this is source 2, this is source 3, and this is 4. Same way, target 1, target 2, target 3, and then target 4. So the thing is, let's assume source system 2 wants to connect to target system 3. Now, let's assume we are using something called Apache Kafka as a messaging backbone, as a messaging system. Now, source system connects to Apache Kafka. So in Kafka, we have something called topic. Topic is, very powerful word in Kafka. Like, if any of you having a background of IBM MQ, in MQ we are having something called queues, local queues. Like that, in Kafka we are having something called topic. So all the messages will be transported through this topic only between the applications in Kafka. So what is this topic? In the technical introduction, we are going to take a deep dive of the topic. But right now, just assume that there is something called topic, which is a very powerful word in Kafka. So let's assume we have something called topic 1. So source system will connect to Kafka and put the message into this topic 1. And the target system 3, it will connect to the same Kafka and same topic, and it will consume the messages. So ultimately, source system is talking to target system via Apache Kafka. Now let's assume source system 4 wants to connect to target system 1. So the thing is, I will build one more something called another topic, say topic 2. Now this source system 4 will connect to topic 2 in Kafka, and target system also connects to topic 2 in Kafka, and the message will be transported from source system 4 to target system 1. So, like this, you can establish a communication among the applications, among the millions of applications with the help of Kafka. So, like Kafka is just like a router. So all your applications connect to this router. Now Kafka takes the load. Kafka takes the load of your distribution. How to distribute your messages. Okay. So like in our home, we have a router, right? We have a Wi-Fi router. I can connect to my laptop. I can connect to my mobile. So I can connect a number of systems, right? Now the load will be on the router. Like this, the load will be on the Kafka. So Kafka is, it's a highly powerful messaging backbone. It's really an emerging thing these days. What it will do is, the purpose of Kafka is only one thing. It will manage the communication among the millions of applications in a simple fashion, in a decoupling fashion. Decoupling fashion means, the target system and the source system, they don't have a direct communication. They will be having an indirect communication via Kafka. So being a Kafka administration, our main role is we have to manage the instances, Kafka clusters. So in the entire training, we are going to see how to build this Kafka cluster, how applications are going to communicate, how messages will be produced, everything we are going to see that. Hope you got some familiarity now, why we need to use Kafka, what is the purpose of Kafka, right? Any questions in this slide, guys?
Yeah. So this can be also achieved by the IBM MQ, right? What is the difference
Uh,
that we found?
Yes, exactly. Good question. So the thing is, the purpose of IBM, the purpose of Kafka, both are same. Both are messaging technologies only. But MQ is a product of IBM. Kafka is a product which is having open source, and also a licensed version of Kafka is also there. The thing is, IBM MQ is a one-on-one communication. Like first message comes, first message goes. Now second message comes, second message goes. Third message comes, third message goes. It's like one-on-one communication. But Apache Kafka, it's a streaming application. Like millions of messages can hit your topic one time, and millions of messages can be consumed by millions of applications at the same time. So Apache Kafka is a completely multi-node cluster, but IBM MQ is one server. So the thing is, the throughput in Apache Kafka would be really, really high. The main purpose of Kafka is throughput. But the throughput is not that much high in IBM MQ. In IBM MQ, it's a one-on-one communication. But IBM MQ is having its own feature. For example, if you go to banking system or financial messages, when you are handling, highly sensitive data, which is very, very secure data, you need to transport them. Then, and you don't have any concern about the throughput, then yes, you can go to IBM MQ. You can purchase that product from IBM and you can use that. But Apache Kafka is completely different thing. Although it is a messaging communication tools, in big data world, Apache Kafka is the best one for the messaging application communication, because it can handle streams, it can handle millions of messages per second. That's the difference between Kafka and IBM MQ. Is that answer your question?
That is, but still, I mean, I think we can also use the same concept in the MQ perspective, because we have like one to many connectivity also and many to many connectivity also is there in the MQ as well, right?
But Kafka is one-on-one communication, right? See,
Mm-hmm.
the thing is, once message has been delivered to applications in IBM
Mm-hmm.
MQ, the message won't be there in MQ. It is vanished, right? It is gone. But
Okay.
in Kafka, there is something called a retention time period. Like once a source system has put a message in topic, there is some retention period in Kafka. Let's assume by default, when a message comes to Kafka, it will be there for 7 days in Kafka. So within
Even
7 days,
after, even after consuming the message from the target system also.
exactly, that's right.
Acha, okay.
So the thing is, While let's assume the target system has, so the source system has put the message in topic, and now the topic will be retention for 7 days. Now within 7 days, how many millions of time target system can consume? That many millions of times Kafka will give the message, because Kafka will store the message for 7 days. And let's assume the target system has consumed it for the first time, and let's assume the process has gone wrong. Although the process has gone wrong, target system again will connect to the same topic, and it will again consume the messages within 7 days, and it can process one more time. But in MQ, you don't have such kind of functionality. Once it's consumed, it won't be there in MQ. It is gone. Again, you have to ask your source system, hey boss, please send me the message again, because my process gone wrong and I want to reprocess it again. So you have to, every time you have to ask with the source system. But in Kafka, there is something called retention time period of 7 days, which is a default one. So within 7 days, you can consume the messages for n number of million times, and you can process it if it gone wrong. Understand?
Yeah, got it. Thank you.
All right. Okay. So let's move on. Now let's see what is Kafka. So Kafka is a powerful messaging system mainly to decouple the data streams on the systems. Like there would be no direct coupling fashion. There is no direct communication between source system and target system. So Kafka allows source system and target system to communicate in publish subscribe mechanism. So it means source system publishes the messages into Kafka, and the target system who are waiting for that particular messages from that particular topic, they can consume it. So the publisher publishes the messages. They are the producers, and the subscribers, they are called as consumers. They can consume the messages. So let's see what are the advantages we have with Kafka. So, okay, so Kafka is the concept of Kafka. Initially, it is created by LinkedIn. So I hope you all are professionals. So you must aware of. I'm damn sure you know what is LinkedIn. So LinkedIn, the people, some people who work in LinkedIn, they have created this Kafka concept. But now it's now a open source project. So right now, the major vendor of Kafka is Confluent. Like for MQ, how IBM is the vendor. Like for Kafka, the major vendor is Confluent. So in this training also we are going to learn Confluent Kafka only, because that's now booming. So you might be having some question like we are saying Apache Kafka, but now I'm saying Confluent. What is mean by Apache Kafka? What is mean by Confluent Kafka? Is there any difference? The answer is simple, guys. There is no difference between Apache Kafka and Confluent Kafka. Both are same. Let's assume you have worked on Apache Kafka for 5 years. Later on, you have moved to a project where Confluent Kafka is there. And don't say that I don't know Confluent Kafka, because Apache Kafka, Confluent Kafka, both are same, guys. Confluent Kafka completely inherited the code from Apache, and they have added their own features. That's it. When you have worked on Confluent Kafka, you can definitely work on Apache Kafka. When you have worked on Apache Kafka, you can definitely work on Confluent Kafka, because both are same, literally no difference. But on the top of Kafka code, Apache will be having its own features, Confluent will be having its own features. That's the only difference, nothing else. Okay, so yeah. So in Confluent also we have open source Kafka community, and we have enterprise Kafka system. So whatever the you use, you can use it. You can download the code from Confluent website, and you can deploy it in your real time project, and you can use it for your live applications. Absolutely no issues. So right now I'm working for a project where we are completely using open source content Kafka only, completely content community we are using. We are not paying even a single penny to content for using that, because it's open source we are using. But the drawback is there would be no support from Confluent. Whatever the big issue you face, everything you have to fix it on your own. That's it. So Kafka is a distributed, resilient, and fault tolerance architecture. So let's see what is meant by distributed, what is meant by resilient, and what is meant by fault tolerance. So let's talk about distributed. So data is distributed in more than one system. So for example, Kafka is always a cluster. It could be a single node Kafka cluster, or it could be a multi-node Kafka cluster. So let's assume there is a multi-node Kafka cluster, and when a message has been published into Kafka, it is not stored in one system. It will be distributed among the systems. Like for example, I have 10 nodes in my Kafka cluster. When a message is being published into a topic, then the topic will be distributed into the 10 systems. Like, so whenever topic is distributed in 10 systems, so the message is also distributed in 10 systems. The advantage of this is out of 10 systems, although if three systems are down, still seven systems are there to serve your application. So the end users, they don't feel any downtime. So that's the advantage of Kafka. But in IBM MQ, when a message is there in queue, it will be there in that particular queue manager. If that queue manager server is down, that's all. You can't access that queue because MQ is a one-on-one communication. But Kafka is a fully distributed. Although in cluster, two or three systems are down, that's fine. Still another systems are there to serve your message, to serve your application. Now let's come to resilience feature. So Kafka having some amazing, beautiful concept that is called resilience, which means capability of recovering in a quick manner from unexpected failures. Which means if some unexpected failure is there, right? In 90% of the cases, Kafka will recover it automatically. That's the advantage of the Kafka because always Kafka is a cluster, right? So what is meant by cluster? If something is down, another thing will be there to serve your application, to make that business work. So that's what the resilience is. Now, fault tolerance. Fault tolerance means simple, we are discussing about that. If one system is down, another system is still available to serve the application. That's called fault tolerance. So the difference between MQ and Kafka is this thing, guys. So there is no fault tolerance in MQ, but there is a fault tolerance. By default, fault tolerance will be there in Kafka. In MQ, if you want to achieve a fault tolerance concept, we have to go with the multi-instance concept. Some additional things are there where you need to have very in-depth technical deep dive into MQ. But Kafka, by default, this fault tolerance architecture will be there because Kafka is itself a full-fledged cluster. So it's a horizontally scalable, which means initially you can build your cluster with one node and you can keep on increasing whenever business increases. For example, today I have Kafka cluster with one node. So next week I can scale it to three nodes. Next week I can scale it to 10 nodes. Next week I can scale it to 1,000 nodes. There is no limit, guys. Kafka cluster is completely scalable. So you can scale up to hundreds of brokers. Broker in the sense it's like a Kafka server only. Kafka server we can call as a broker in Kafka. So it can scale millions of messages per second. So this is the another advantage of Kafka. So the thing is, I was reading an article a few days back, and there is a company called Uber. I know you guys. I mean, I'm damn sure you know what is meant by Uber. It's a app-based cab service. Uber, they completely use Kafka only, and out in 24 hours of time, Uber process 7 trillion of messages per second. Sorry, per day in 24 hours. So 7 trillion 24 hours means it's really huge. So there is no limit in Kafka. You can scale millions and trillions of messages per second. So it's a high performance. The thing is, I already told you, right? In 1 second, you can process millions of messages. So really, the performance would be really huge in Kafka. So the purpose of Kafka is to process really tremendous volumes of data. That's it. So right now, Kafka is used by 2,000 plus firms, like around 35% of Fortune 500 companies, they are using Kafka. So out of them, like Airbnb, Netflix, LinkedIn, Uber, Walmart, all these companies are now using Kafka. So clear with the advantages, guys? Any questions?
So Mohan, Confluent Kafka is also a open source.
Yes. Content Kafka open source is there and enterprise version is also there.
Okay, so which version of Kafka are we gonna discuss?
We are going to use Content Kafka 6.2, which is the latest version.
Mm, okay.
I will show you, like once these PPTs are done, I will open Confluent website and I will show you what are the available versions are there for Kafka.
Yeah.
Okay, now let's see what are the real-time use cases of Kafka. So Kafka is a powerful messaging system that we have already known by this night. Now it is used for activity tracking. I will tell you. So the thing is, Kafka is a very excellent tool for activity tracking. So okay, for example, I have opened a website called Flipkart, and I tried to purchase a mobile. I have searched for so many mobiles. I searched for iPhone, I searched for Android phone, OnePlus, Samsung. I searched for many phones, but I have not purchased it. So I have closed the browser. I have shut down my system. And next day, again I open my laptop. Again I just open Flipkart.com website. As soon as I open Flipkart.com website, on the left hand side, on the right side, or top or below, some flash will come. Hey, this mobile is having this offer. This mobile is having this offer. So Flipkart is having that ability. I don't know if you have noticed that functionality or not, but the thing is, how Flipkart came to know you are looking for a mobile for the second time? When you open the laptop for the day two, it is showing the advertisements. Okay, this company is providing this offer, this mobile is having this offer. Why they're showing that? Because the previous day activity, what you have done, they have tracked it. So they might be under the assumption, okay, you might be interested in purchasing a mobile. Okay, if they filter some offers good for you, they can show you, maybe you can purchase that mobile, maybe business to happen to Flipkart, right? That might be the reason. So they can track your data, and they can automate something, and they can show you, okay, this is having some offer for you. So if you really love that offer, if you really like that offer, you can purchase it, so that business will happen to that particular Flipkart company, right? So like that, activity tracking can be done for the applications, and gather metrics from different locations. Let's assume I have Android mobile. Android is now managed by Google, right? So let's assume I have visited some mall today, and next day morning when I woke up, right, my Android phone show me, hey Mohan, yesterday you have visited this place. Please provide your feedback, like how to access this. Is this facility is there? What is the car parking facility? They will ask some feedback from us, right? Now, how does that phone, that application know that I have visited this location? Because they have something called metrics location gathering. With the help of a location gathering, they can imagine, okay, he visited this place, fine, take him feedback, so that they can put it on a public website, so that other people they can review it, they can see that. For them, it will be easy. So for such kind of things, Kafka can be used. And application logs gathering, so gathering application logs is one of the toughest jobs. So for example, application will be deployed in the Linux, or I mean in some Unix flavor systems, right? So whenever any application is there, definitely logs will be recorded, right? But the thing is, being a developer, being an end user, if you want to see the logs of particular application, the thing is, you have to log into the Linux server, you have to open the file, you have to search. It means some technical knowledge you need to have, which is not needed for the end users, right? So the thing is, when Kafka have the logs gathering functionality and put it in some nice graphical user-friendly format, it would be very easy for the developers, right? So the thing is, we have something called ELK. I don't know how many people have heard about ELK, Elasticsearch. So Elasticsearch is something, it will gather the information and put it in some nice UI, some user-friendly dashboard, so that people can see that, okay, this is my log. So they can easily search for it. So for this kind of logs gathering also, Kafka will be used. And it's a stream processing. I already told you, Kafka is for managing millions of messages per second, which means it's a stream of messages. So the thing is, to manage the Kafka stream processing, there should be a lot of APIs we need to develop. But the thing is, this API development will be taken care by Kafka developers, but we are Kafka admins. Being a Kafka admin, we are not going to learn how to develop this stream processing and all, because I myself don't know how to build this Kafka stream. Because Kafka stream, to build a Kafka stream application, you need to have a lot of knowledge in the coding part. So from the coding part, I have very minimal knowledge. So stream processing we're not going to discuss, but with the help of stream processing, once you have a Kafka stream API built, then you can manage the streams. So decoupling of system dependencies, like there is no direct dependency between source and target system. It's completely decoupling fashion. So it can integrate with the big data technologies like Spark, Flink, Charm, Hadoop, and many other big data technologies. It will perfectly fit, because Kafka is to manage really huge data. So huge data means it comes under big data world. So for big data, to serve the messages, to serve the data to big data, Kafka is one of the best tool. So clear with the use cases, guys? Any questions here? All right, let's move on. Now let's come to history and versions of Kafka. So Kafka is developed on Java and Scala languages. So even when we want to install Kafka in any system, right? First of all, we need to have Java installed on that machine. Without Java, Kafka will not work because Kafka itself developed on Java and Scala languages. So Kafka is officially launched in Jan 2011, and there are various versions of Kafka. So like Kafka 0.x, Kafka 1.x, Kafka 2.x. Right now, the most stable release of Kafka is 2.8. So now I think 2.8.1 has been launched on 19th April 2021.